This is the video for Unit 3, Day 4, Section 10.5. These are the bolded problems. We're going to start with number 5. And what we're doing with these problems is translating from English, quote unquote, to algebra, quote unquote. One of the things I want you to think about when we look at these kinds of problems is you have to figure out sort of what the heart of the problem is. Look for the heart. That piece of the information is going to be what your x is. So let's take a look at this first part. Number 5 asks us to find 5x decreased by 6. Well, as I look at this, I know that decreased means to subtract. And so that means I'm going to subtract 6. They gave me x and 5 x's. So 5 x's decreased by 6. If I look at this particular example, 5x is the heart. Okay? So here we have 5x decreased by 6. Please notice that there's no equal sign, so this is not an equation. This is simply an expression. Let's look at number 7. 3 times the sum of x and 1. Well, I'm going to look for x, the sum of x and 1. Sum tells me I need to add, and that tells me I need somehow to add x and 1. The sum of x and 1. That's what that looks like. And then I go back and I say 3 times that. So that's what that's going to look like. And here the heart of my problem was this right here, the sum of x and 1. Again, that's an expression because there's no equal sign. Number 15 does give us a little more information than we had before. So these are probably going to be equations. So this one says when 6 is subtracted from 5 times a number, the result is 9. I want to take this apart, and the first thing I'm going to notice is the words the result is 9. Result is code for equals, so equals 9. Now I'm going to go back in and I'm going to look for the heart of the problem, and I'm going to say when 6 is subtracted from, I'm going to subtract 6. So minus 6. So the heart of the problem, let's do it in pink for Valentine's Day, which is nowhere near now. There is the heart of the problem. 5 times a number. So let's see, let's double check. 5 times a number minus 6 equals 9. So let's see what that would look like algebraically. Here's one of my handy forms that I'm going to use to solve the problem. First of all, I'm going to quickly identify which side is the variable side and which side is the home number side. Here's the home of the variables. That's for the numbers. The first thing I want to do, and pardon me while I speed through this number does not belong, so I'm going to add its opposite to both sides. That zeroes out. That leaves me with 5x equals 9 plus 6 is 15. Now I'm going to divide that out, divide that side by 5, divide that side by 5. That's a 1, leaves me the x. 5 goes into 15 3 times. So my answer is, according to this, x equals 3. Let's double check. 5 times 3 is 15, and 15 minus 6 is 9. So I got that one right. I sound surprised, I know. Here's another one, number 17. 3 times the sum of a number and 1 is 18. So there's is. That kind of tells me that that might be part of the answer. So I'm going to start with that. Is 18. 3 times the sum of a number and x. Well, I'm going to see the words the sum of a number and 1. So some number plus 1. That's how I would say that. The sum of some number and 1. And then if I look up here, that's 3 times that. So take 3 times x plus 1 equals 18. And again, the heart of this problem is the x plus 1. Let's see what that looks like if we work it out. First rule, variable numbers. Good. Then I'm going to distribute. 3 times x is 3x. 3 times positive 1 is 3, and the 18 just comes down. This doesn't belong, so I'm going to take it away. Add the opposite, add the opposite. That's 0, so 3x equals 18 minus 3 is 15. Divide that out, divide that out. That's 1. X equals 3 goes into 15 5 times. And 5 plus 1 is 6, and 6 times 3 is 18. 18 equals 18. Here's another one. This is a little more challenging because it requires a little background knowledge on your part. If you read a problem and you don't know what a word means, please look it up. There are dictionaries everywhere online, and even sometimes there are glossaries in the back of your math book. Perimeter here is a good vocabulary word. It's the measurement around a figure, not inside, but around the edges, if you walk around the block. One way to remember it is the word rim is in perimeter, and this is the rim of the figure. In this case, sometimes it helps you if you draw a picture. So here they're asking about squares, and again you have to rely on your background knowledge that tells you that a square is a rectangle that has all sides equal to each other. That's an important fact. And it tells you that if you went all the way around this square, the answer would be 32 centimeters. And they want you to find the length of one side. So if I know that, I'm going to keep my picture here. If that side plus that side plus that side plus that side equals 32, I could write this as side plus side plus side plus side equals 32. Wow, that's a lot of work. If I wanted to do that more efficiently, I could write it as 4s equals 32. Let's see how that would look to solve it algebraically. This one's pretty simple. I don't have, it's obvious the variables are here and the numbers are here. I don't have anything to add or to subtract to get rid of, so I'm going to go right to division. So here we go. I'm going to take care of that 4. I'm going to take care of that 4. There's a 1. Have my s equals 4 into 32 is 8. So the sides of the triangle equal, or square, each equal 8 centimeters.